Section 8.2 is probably the biggest one in this unit. It deals with human impacts on aquatic ecosystems, but it's not overwhelming because we've talked about 90% of this content. We just haven't talked about it all together in one place. So it all should be familiar. One of the things that we need to review is organisms having range of tolerance for various pollutants. Organisms have an optimum range for each factor where they can maintain that homeostasis, that perfect condition in order to live. Outside of this range, organisms experience stress, physiological stress, limited growth, reduced reproduction, and in some extreme cases, death. So we need to have certain conditions in order to live. Coral reefs provide quite a few benefits. They provide biodiversity and habitat. They provide shore protection. They're good for tourism. They're used as a food source. They're used for medicines. If we look at this infographic right here, they're home to a quarter of the world's marine species. They provide food to more than 500 million people that live near the coast. They provide livelihood for millions of individuals. They serve as marine barriers and protect coastal communities. And important medicinal components have been found in several marine species that inhabit coral reefs. There are many threats to coral reefs. Take a look at how pretty this coral reef is. Things like boat damage, anchors, chains, snorkelers and divers. We talked about different types of dredge fishing that can ruin coral reefs. If we look at this billionaire's luxury yacht, it damages sensitive coral. It was too close to the ground, it ran over it. Other things like blast fishing or cyanide poisoning. And overharvesting is another one. So many fishing methods that we talked about earlier in the year when we're talking about large-scale fishing can be dangerous to coral reefs. There's also chemical impacts to coral reefs, as well as sedimentation, extra sand and things laying there. Oil spills, like we talked about, can be dangerous to coral reefs. Microplastics. We talked the other day about plastic breaking down, and it doesn't really go away. It breaks down into smaller and smaller and smaller pieces, but it's still there. So plastic doesn't truly decompose, and this can be dangerous to different corals. And then we also have rising sea temperatures. So if we have rising sea temperatures, it allows the coral to become bleached. So a healthy coral requires algae to survive. It's both the coral's primary food and what makes it colorful. And when it's stressed, rising ocean temperatures and overexposure to sunlight stress coral and cause algae to abandon it. When the algae is gone, the coral turns white and it's more susceptible to disease and death. Other things that can impact coral reefs are toxins, sunscreens, pesticides, metals. If you've ever gone snorkeling in a coral reef, a lot of times you have to wear reef-safe sunscreen, ones that are physical barriers, and not the sprays that we tend to like to use. There's biological things that impact coral reefs. There's invasive predators, lionfish, crown-of-thorns, starfish. So we have these invasive species that can do a lot of damage to coral reefs. Here's a underwater robot that seeks to kill invasive starfish. It's just kind of a crazy idea as a way to solve a problem. And then there's pathogens, there's infections. So this is just an example of an infection, black band disease, which is a bacterial infection for coral. How does human activity magnify all these different threats? If we're looking at storm impacts, we can tie that into climate change. We have bigger and more frequent hurricanes. Temperature change is also due to climate change, which is going to change the way the currents are moving. Climate change is going to change salinity, so we'll have melting ice, which will dilute the concentration of the salt water. We'll have predation, so you have invasives, aquarium pets that are being released into areas where they shouldn't be and reproducing, and boat ballasts. Boats, in order to balance themselves in the water, take in water from where they are, and then they move to a new location, and when they want to rise higher in the water, they let that water out. And that can have all sorts of organisms in there. Zebra mussels were spread that way. That's a sort of famous story about that. And then algae overgrowth. So sedimentation from developments, eutrophication, nutrients, things that we are putting into water to cause eutrophication. Oil spills. We talked about oil spills already, but oil spills are in here as a human impact on the ecosystem. We already talked about how it coats the feathers and fur of marine mammals and birds. Fish, they have health issues and death from ingesting oil. It can block their gills. Invertebrates, things like starfish and crabs, they get smothered or immobilized by being covered in oil. And just to review a couple oil spills, we talked about the Exxon Valdez oil spill in 1989. It was the supertanker that crashed into a reef in Prince William Sound. 11 million gallons of oil was spilled, and 500,000 birds and thousands of marine mammals were killed. And they're cleaning the shore there with their hoses and paper towels. There's a lot of talk about the Arctic National Wildlife Refuge. Exploration could yield up to 1.4 trillion liters of oil and natural gas, but opponents to this say that it will harm the pristine habitat and the human population as well. You can take a little look as to where that Arctic National Wildlife Refuge is, up in the upper right-hand corner of Alaska. It's the same size as South Carolina, which is kind of crazy. And then the Deepwater Horizon in 2010. It was the explosion at the BP oil rig in the Gulf of Mexico. It released 780 million liters or 206 million gallons for 87 days, and it killed 6,000 sea turtles, 26,000 marine mammals, and 82,000 birds in that. Wastewater, so we're talking about sewage, which is produced by livestock operations and human activities. A quick little review of knowing your water. We know we have our clean water. We have our gray water, which comes from baths or sinks or washing machines. And then we have what we call black water, things that come from toilets or dishwashers. I think certain dishwashers could also be gray water, depending on what kind of detergent you use. Why is wastewater a problem? Wastewater, when we get that into water, has a high BOD, that's that biochemical oxygen demand, or biological oxygen demand. You need more oxygen required for the bacteria to decompose all of that organic material. So we saw that when we did the lab with the yeast. If you have a higher BOD, it means you have more pollution. You have more of those nutrients in the water. Higher BOD, when we have higher biological oxygen demand, we have less dissolved oxygen. Then we have less dissolved oxygen that are present for other forms of life, and it forms what's called dead zones. This is showing the Gulf of the Mississippi River here, in the Gulf of Mexico there, where the Mississippi River drains into the Gulf of Mexico. There's so many nutrients that come down from all the farming, so we put all those nutrients in, causes sort of the algae blooms, it continues to move down, the oxygen gets used up by the decomposers, and very little lives at the mouth of the Mississippi River, which is crazy. It's one of the biggest dead zones there is. How's the dead zone formed during the spring? The sun-heated freshwater runoff from the Mississippi River creates a barrier layer in the Gulf, because if that warm water's on the top, cutting off the salty water from down below with contact with the oxygen in the air. That warm water also won't hold oxygen very well. Remember, we know cold water holds oxygen. Nitrogen and phosphorus from fertilizer and sewage in the freshwater ignite huge algae blooms. When the algae die, they sink to the salty water below. They decompose and they use up all the oxygen in the deeper water. And then, starved of oxygen, cut off from resupply, the deeper water becomes a dead zone. The fish avoid the area or die in massive numbers. This is looking at what happens when you have point source pollution. So a lot of times you don't see the effects until much later on downstream. The point source pollution, you have this normal clean water right here. It's flowing down the stream. If you see what happens, we have this huge biological oxygen demand spike right where that pollution is coming in. So we'll have that huge use of stuff that the algae, and then we get to that decomposition zone, and you notice as this rises, this dissolved oxygen follows a little bit behind it, and that drops way low. And then as we move further down the stream, this is going to go down, the biological oxygen demand is going to go down. It's going to allow the dissolved oxygen to repair itself. Lead is a pollution in water. We can have lead pipes, lead paint, lead toys, lead older apartment buildings. We talked about that. Arsenic is naturally found in the soil and can also be released from mining, but we know too much arsenic can be dangerous. Mercury comes a lot from coal, burning of coal and burning of garbage. We talked about that. Coal also puts sulfur in the air, but here we're talking about mercury. Once it's airborne, it can fall onto waterways and into seafood. That little spot, this much mercury can contaminate a 20-acre lake, so it really doesn't take much. And bacteria convert it to methyl mercury. Regular mercury, your body sort of gets rid of. Methyl mercury is the very, very toxic form. Acid rain we spend a lot of time with. So we have that coal in particular that puts the sulfur into the air. We also can have cars that put nitrates into the air, which is going to make that acid rain, which is going to make our water more acidic. We can have pesticides, which can be a pollutant. So we increase our crop production, but then we know the pesticides, the nitrogen, or the pesticides, which will kill the organisms, which is different from our fertilizer, which will put nitrogen and phosphorus into the water and cause eutrophication. So remember, we want to keep those two separate. We can get pharmaceuticals, which end up into the waterways many, many times just by people when they don't know what to do with their extra medications. They flush them down the toilet, and this actually is a significant problem in terms of it getting into the water cycle. Perchlorates are part of rocket fuel, so we have contamination in different areas where we see that. PCBs are polychlorinated biphenyls. They're used for plastics and different electrical things, sometimes cases of computers and stuff. We know that to be highly cancerous and highly toxic. We try to use less of that these days, but still there's quite a bit. PBDEs, which are flame retardants, we find them in insulation and upholstery and plastic casings and dust and carpet padding, some baby products. These flame retardants, which protect us from things being on fire, are also a source of water pollution. Sediment pollution, we talked about this from being behind dams, from construction. We can get too much sediment, from agriculture, from erosion. If we clear cut land, we can have too much sediment. It increases the turbidity, or the inability to see down to the bottom of that water. It reduces the sunlight. It can physically clog the gills of fish, and it can lead also to eutrophication.